Hello guys, good evening everyone, and welcome back to 360DigiTMG's data domain analytics program. In last class, we are discussing about the transportation analytics from last 2 days, and this is the third day. And the very first day that we have discussed, what are the applications? Yeah, in the very first day that we have discussed about the applications of machine learning or AI and machine learning in the field of transportation. Where exactly we can apply the machine learning, where do we need improvements, all those things that we have discussed in the very first day. And in the second day we have discussed about CRISP-ML methodologies. What is CRISP-ML? Cross-industry standard process. So irrespective of any industry, or that could be any domain, irrespective of any domain, we'll be applying the CRISP-ML methodology in order to do the data science project. So what are those different phases we'll be having? In each and every phase, what are the things we'll be doing? What is the process? What is the sequence when it comes to data science project that you have discussed in the last class? And in today's class, we'll be discussing about EDA, that is EDA and pre-processing. What is EDA? Exploratory data analysis and pre-processing. So whenever we are working on the data science project, so you need to have a data that is called historical data. We'll be calling it as historical data. Using those historical data only, we will be doing the predictions or any segmentation. All those things we'll be doing right after using the historical data only. So whenever you are collecting the historical data, you might, it is the raw data. It is not the pre-processed data. Whenever you have a raw data, in that case, we will be having so many anomalies. Anomalies means errors, you can say, or missing values. So like that, we will be having so many anomalies we will be having. What are those anomalies we will be discussing in detail, and how we can do the pre-processing, how we can clean that particular anomalies. That is where we will be using the pre-processing. Once it is done, we will be doing the exploratory data analysis. So whatever the data we'll be having, we will explore the data and we'll try to find out the inferences from that particular data. That is where we'll be using the pre-processing. Before starting the session, we'll simply look into what are the agenda when it comes to today's talk. So we'll be discussing, like I said earlier, exploratory data analysis and data pre-processing. Actually, whenever you are collecting the data, these data are three types. Those are unstructured data, and structured data, and semi-structured data. So when it comes to unstructured data, what does it mean? So when the data is not in the form of tabular form, if it is not in the form of rows and columns, in that case we'll be calling it as unstructured data. For that, examples are textual data, and videos, audios. So these all comes under unstructured data. In these data, we won't be able to maintain in the tabular format. And then we have structured data. The data that is present in the form of table, column and rows, will be calling it as structured data. And then we have, for examples for the structured data, you can say SQL query, whatever the data that we are storing in the SQL servers, all the servers data we can call it as or you can say all the server data. I mean, SQL means all the data will be stored in tabular form, right? Columns and rows. So these we will be calling it as structured data. And when it comes to semi-structured data, that is XML file, HTML. So whatever the data, we can be easily able to convert that unstructured data to the structured form. We can easily convert that unstructured data into structured form. That will be calling it as semi-structured. So for each different, I mean, we'll be having different data, right? So for structured data, we have some pre-processing techniques, and for unstructured data, we'll be having the different pre-processing techniques. So what are those pre-processing techniques? Before getting into that, what are the exploratory data analysis? What we will be doing when it comes to exploratory data analysis, we'll see that. Exploratory data analysis. So right after receiving the data set, the very first thing that we will do, exploring the data. Exploring the data analysis refers to critical process of performing the initial investigation. So we will be getting the problem statement, right? Let's say you got some loss in your business. You got some loss in business. To understand why we got into the loss, we'll be having the data. So we will be doing the investigation into the data to find out what could be the reason for the loss. So when you have all the historical data, in that case, you can easily figure it out what could be the reason. That is where we will be doing the exploratory data analysis. To discover the patterns and spot anomalies, if you have any missing values and dummy variables, duplications, and if you have anything, if we are doing the visualization in exploratory data analysis only, we'll be doing different visualization. Using those, we might be finding some patterns. Because of that reason, we might be getting into the losses. So these are all things we'll be doing in exploratory data analysis. In exploratory data analysis, what are the questions that we'll be asking? Very first questions. Is there any existing unique value records we'll be having? Like, do we have any IDs? So if we are dealing with banking data, in that case, every person will be having some ID, right? Or if you are dealing with some organization data, in that every employee will be having the different records, IDs. Our fields, I mean, we'll be asking these questions, whether we have any unique values or records or IDs are there. Are fields populated with numbers, date, I mean, whatever the data that we'll be having, whatever the historical data we'll be having, in that, do we have any fields or features related to the numbers, dates, alphanumerical characters? So what is the distributing, I mean, if you have a numerical values, so what is the distribution of those numerical values? How can we find out the distribution? We'll be having mean, median, and mode is for categorical data. When you have a numerical data, we'll be applying the mean and median, and then we have dispersion. So we'll be finding all this, how the distribution is there of those particular numerical values. If you have numerical features, what is the distribution on average? So those all things we'll be finding out. How many values exist for the categorical fields? When you have a categorical fields, how many unique values will be having in your categorical fields? How many fields have been left blank? If you have any missing values or not in that particular data, how are the multiple data sets are related? Do we have any correlation in between the input data variables? I mean, whatever the data set that we are taking, do we have any correlation in between the input columns and the output columns, or in between the input columns? All those things will be finding when it comes to exploratory data analysis. So in exploratory data analysis, we'll be having some graphical representations. Using the graphical representation also, we can easily find out how the data is spreaded, how the variation is there, how the data is spreaded. For that, we have different graphs. I will go through one by one. We'll be having univariate graph, univariate analysis. In that univariate analysis, what we will be doing, we'll be using just one single variable, that is single variable. Single variable means any one feature. We'll be taking one feature and we'll try to analyze that particular feature. For that, we'll be having the univariate analysis. And just one variable to summarize that variable. For that, we'll be having bar plot, histogram, and box plot. In bar plot, what we'll be doing, if you have different unique values, how those values are spread. If you have a histogram, whether that particular variable that you are using, is it symmetrical or not? How data is spread, that also we can find out using the histogram. Whether whatever the data we'll be having is symmetrical or not. And we'll be having the box plot. It is also comes under univariate analysis. Using this box plot, we can figure it out whether we have any outliers in our data or not. We'll be having something like that. Using this, we will be finding out whether we have any outliers are there or not. So for that, we will be using the box plot. And then we will be having the bivariate analysis. In bivariate analysis, what we will be doing when it comes to univariate, we are simply using single variable. But when it comes to bivariate, we will be using two variables or two features of that particular data, whatever the data frame that you are using, and we'll be simply calculating the relation between both. For that, we will be using, it is the example of the bivariate analysis, scatter plot. Using scatter plot, what we will be doing, whatever the feature that we are using, are those related in some way? The correlation that we'll be finding out the correlation between the two variables. This is where we'll be using the bivariate plot. Example for the bivariate plot, we'll be having the scatter plot. And then we have a multivariate analysis. When it comes to multivariate analysis, we'll be finding the relationship between all the input variables to output variable, or in between the input variables, all variable we are taking at a time, and we'll be finding the correlation or any kind of relationship between all those. So for that, we can simply use pair plot. We'll be having the pair plot, all the feature at a time we'll be finding out, and then we have a heat map as well. So what is whatever the correlation between individual features like x1, x2, x3, x. If you have something like that, it will simply show all the correlation between different features, x1, x2, x3. So here diagonal column is comparison between them itself. In that case, we'll be having just 1, 1. Since the correlation between the same, it will be always 1, right? So then we'll be finding out the correlation between other features, how correlated these features are. Using pair plot, we will be easy to find out that correlation. This is multivariate analysis. Here we will be using the more than 2 variable for the finding the relationship. And when it comes to statistical analysis, in exploratory data analysis only, we'll be having statistical analysis. In that, we have different business moment decisions. So just by going through the symmetry, how the data is created, we can make some business decisions. What are those business decisions? We'll see. First moment business decision. In the first moment business decision, we will be having mean, median, and mode. So whatever the data frame we'll be having, whether it is numeric, if it is numeric, we'll be finding out mean and median. Mean means what? It is average only. So if you are running some business, in that case, the very first question anybody will ask, what is that? How much you will be earning on an average? So when you have when you don't have any outliers, what are those outliers? We'll be discussing in a minute. When you don't have any outliers, in that case, we'll be going with mean. When you have an outliers, in that case, we'll be going with median. When you have outliers, mean will be getting affected. That is the reason we'll be avoiding. When you have outliers, we'll simply go with median. When you have outliers, and if you are going with median, median won't be affected with the outliers at all. And when you have a categorical data, in that case, we'll be going with the mode. And then this is also called as a measure of central tendency. Both are pretty much average only. This is, we'll be calling it as measure of central tendency. And then we'll be having second moment business decision. So it will talk about how the dispersion, how the data is spread. Let's say if I'm talking about just age data. So what is the range of the age data? If we are calculating the mean or median of that particular age data, how the data is spread. Let's say it is 32, mean is 32. How spread of the data is there in our particular data? All the values won't be present on the mean itself, right? Mean, average will be calculating, but from average, how this data is spread, that will be finding out using what? Measure of dispersion. This all will give you the measure of dispersion. Variance, it is spread. We can also call it as information, how it is spreading from the data. Mean and standard deviation as well, how the data is spread from the mean. That we will be finding out using the second moment business decision. So we'll be calculating what using this, whether data is symmetric or not. If it is not symmetric, in that case, we will be converting into the non-normal. You can also call it as a normal, whether it is normal or not, or symmetric or not. It is also, we'll be calling it as measure of symmetry, whether that particular data, whatever the variable that you're taking, whether it is skewed, symmetric or not, or we have some skewness. When you have, let's say it is data, and if you have a right skewness, whatever the data, extreme values are on the right side, and the tail is on the right side. In that case, we'll be calling it as right skewed. If you have skewness on the left side, we'll be calling it as left skew. So what are the inferences that we can get from that particular data? You can simply check your products, which are the products are getting sold very frequently, very much high. In that case, we'll be getting the those values in the center, and whatever the values that are not getting, whatever the products that are not getting sold, that in that case will be present in those products will be on the skewed. Those are the skewed value. These are the business decisions that we can make. Which are the products are getting sold, and which are the products not getting sold that much, will be taking into the skewness. And even in the peakness, the kurtosis is also same. The fourth moment business decision. It will simply check peakness of the data, peakness, or you can say tailness of the data. So using this also, we can make so many inferences, whether whatever the products that we will be having are, let's say you are mainly selling the grocery items, whether those are getting sold or not, or the tail products are getting sold much. Which are the products are getting sold very frequently, are very much higher compared to the other? We can simply, using the kurtosis, we can figure it out. These are the business moment decisions we'll be having. Using those plot, we can able to infer. Yeah, we can able to infer things from the data, plots. So this is the exploratory data analysis. When it comes to pre-processing, that too, when I'm talking about structured data pre-processing, particularly if we talk about structured data pre-processing. In that structured data pre-processing, we'll be having, these are the anomalies, like in the very first slide that we have talked about, right? Whenever we are taking the raw data, we will be having so many anomalies. What are those anomalies? These are all different anomalies will be having. Let's say typecasting. The very first one is typecasting. What is typecasting? So in Python, you don't need to mention that this particular data type that you are taking belongs to integer, belongs to float, this belongs to string. These things we don't need to initialize. Python itself take based on the data that is present in that particular feature, it will automatically give what data type it belongs to, whether it is integer, whether it is float, whether it is string. It is automatically detects it. But sometimes, let's say salary data. Salary data can be float. Salary data can be integer as well. Let's say whatever the data that you are taking are in the form of float. That is decimal form. Whatever the salary data you are taking, if it is in the form of decimal, in that case, Python, what it will take? It will take and give the data type as a float. But you don't want that salary data into the float. In that case, what we can do? We can simply convert that float data to integer data. You can convert the float data to integer data. That is, we'll be calling it as typecasting. Converting one data type to another data type, we will be calling it as typecasting. And then we have duplicates. What are the duplicates? Let's say if you have similar entries multiple times. You have similar entries multiple times. What does that mean? Let's say these are the inputs x2, x1, x2, x3. And let's say this is one output. So this is my input. This is x0, you can say 5, 7, 3, 2, and we have output S. So this is one supervised. I'll be going with supervised. In that, I have inputs are this, and again I have one more entry saying that 5, 7, 3, 2, S again. So these both entries are similar, right? Not similar, exactly same. So in that case, the same information you are giving one more time. The same information we are giving one more time. Do we need to do that? Anyway, it is the same information, right? We are giving one more time. That is, we'll be calling it as duplicate data. When you have similar entries in your data frame, we'll be calling it as duplicate data. So you don't need to have duplicate data. Say if you have all the values are all the information is same. In that case, you won't be able to infer anything from data. So we have to eliminate those duplicate data. Whenever you have a duplicate data, what we'll be doing? We'll simply drop those duplicates. We'll simply drop those duplicates. And then we have outliers. To find out whether the outliers or not, we will be using what? Whether we have any outliers or not. For that, we will be using box plot. We have seen in univariate analysis. We'll be using box plot to find out whether we have any outliers or not. Let's say it is a box plot. So whatever the outliers that are present in our that particular variable, it will simply show and the beyond this point. So here we'll be calling it as upper cutoff. Here we'll be having lower cutoff. So whatever the data will be having here, quarter one will be having 15, 75. To find out the outlier, whether we have an outlier or not, we'll be having one method that is upper cutoff value is equal to Q3 plus 1.5 into IQR. IQR means interquartile range, that is Q3 minus Q1. Here Q3 is what? How many values that are present in 75 percentile range. How much data is present in 50 percentile range. How much data is present in 25% range. That could be any numerical value. We will be splitting into these 4 categories. Based on that, we'll be deciding the upper cutoff value and we'll be deciding lower cutoff value. What is the lower cutoff value? Q1 minus 1.5 into X1. So whatever the values that are beyond this, we'll be considering as an outlier. Whatever the values beyond this will also be considered as the outliers values. So whatever the values beyond this upper cutoff, beyond this lower cutoff, we'll be considering it as outliers. So whenever you have an outliers, what we have to do? We can replace it and we can remove it. So when we are removing that particular outliers, in that case, we will be losing the data. So whatever the values that are beyond that upper cutoff and lower cutoff, we are simply removing those. In that case, we will be losing the data. To avoid that, we can go with the replacement. When it comes to remove, we'll be calling it as trimming. When it comes to replacement of those outliers, we'll be calling it as Winsorization. So whenever we have an outliers, Winsorization is recommended. Why? Whatever the values that we are having the outliers, we are not removing those outliers. Here we don't we are not losing any data. In that case, we will be going with Winsorization. What we will be doing in Winsorization, whatever the outliers will be having, if those outliers are beyond the upper cutoff, in that case, we'll be replacing with upper cutoff value. If those values are beyond the lower cutoff value, in that case, we'll be replacing with lower cutoff. So this is how we'll be doing the outlier treatment. This is how we will be doing the outlier treatment. In that, we have 3 R techniques as well. First, whatever the data frame will be having, first we will see rectify, retain, and remove. So these are the 3 R techniques to deal with the outliers. What we will be doing, if you have some extreme values, we will look into it, whether it is happened for just one time or it is a continuous process. If it is a continuous, in that case, it is a genuine case. We will be retaining that particular extreme value. If it is not the continuous form and it is happening in a once in a full moon, in that case, what happens? That data will be simply removing it. So we'll be considering that as an outlier and we'll simply remove those outliers. So we'll be having 2 techniques like we have discussed, Winsorization and trimming. In trimming, we are simply eliminating the data. When it comes to Winsorization, we are simply replacing the data. And then we have 0 and near to 0 variance. Near 0 variance and 0 variance. Whenever we are talking about the variance, we have seen in second moment business decision. Spread of the data. It is a mean how far the data is spread. How far the data is spread. Something like this we'll be having. How far the data is spread. That is only we'll be calling it as variance. But variance only we'll be calling it as information. When come to 0 or near to 0, no variance. 0 variance means no variance. Near to 0 means very small variance will be having. Let's say whatever the data frame you are taking, let's say age data. We have 32, 32, 32, 32. All the data are similar. All the data are similar. In that case, what will be the mean of that particular 32 only? If you find out the variance, in that case, 0 variance. All the data points will be present on the mean itself. So there is no spread of the data. When there is no spread of the data, no information. When there is no spread of the data, no variance will be there. If there is no variance, in that case, no information. When there is no information, why do we need to use that particular data? So what we'll be doing? We'll simply ignore that feature. So if it is not giving any information, in that case, why do we need that? So we'll simply ignore that feature, or we can simply drop that feature. And near to zero variance means most of the data present on the mean, mean only, and very small data is present on nearby. Let's say here in each column, all the data, like 95% data is 32, and the rest we have 5% is other values. In that case, what we'll be having, all those, most of the data is present on the mean, the rest very small values, very small data will be having the spread. So that is variance is near to zero variance. In that case also it is not giving any information. It is also not giving any information. In that case, what will be doing? We'll simply ignore that feature as well. And then we will be having the discretization. What is discretization? So whatever the continuous values will be having. Continuous values means if the data is present in the form of decimal. If that data is present in the form of decimal, then in that case we'll be calling it as continuous. Let's say salaries. 12,500 55 paise, 25 paise, 20,550 paise. So it is in the form of decimal. So we will be calling it as continuous. So whenever you have a continuous data and you are converting that continuous data into bins or categorical or discrete, in that case, we'll be calling it as discretization. When you have a continuous data and you are converting that continuous data into bins, categorical, and discrete, we'll be calling it as discretization. Let's say you have a range of salaries, different range of salaries we'll be having. In that, all the salaries, I'm converting those salaries into two categories. Let's say it is a low and is a high category. High salaries and low salaries. Medium value, that whatever the average value, I'm just taking the average of all those salaries. Whatever the values are greater than the average, I'm considering as a high salaries. Whatever the value less than the average, I'm considering as a low salaries. Now what I'm doing, whatever the continuous values I will be having, I'm simply converting into category low and high. This is we'll be calling it as discretization. And then we'll be having the missing values. What happens in missing values? Let's say you have so this is x1, x2, x3, and x4. So these are the different features we'll be having. In that features, we'll be having the information, right? Let's say it is about some age 25, and it is about salary 25,000, and it is about gender, it is male, and it is about something else. What we can take? Experience. So 5 years of experience we'll be having. So these are the features I'm taking here. All the information is present. All the entries are present. But here I have missing value. Here I have 30,000. Here I have female. And we have 3 years of experience. You can see here we have the missing value. We don't have any information here. When you have something like that, machine learning algorithm, what it will do? It will remove this whole entry. It will simply remove whole entry. Whenever you have one single missing value, it will simply remove all those. To avoid that, so this is we'll be calling the as a missing value. To avoid that, we'll be having different imputation techniques. Imputation techniques. So those are mean imputation, median imputation, and then we will be having mode imputation. Mean and median will be using for the numerical. Mode will be using for categories. So what happens in mean imputation? We'll simply calculate the mean of all those features and we'll simply replace with wherever we have missing value, we'll simply replace with that. When it comes to median, we'll simply calculate the median of that particular feature and we'll replace it. And mode, most frequently occurred element. Whatever that, like it is a categorical data, right? Whichever the having the most frequently, male or female, we'll be finding out that Based on that, we will be replacing those missing values. So this is the missing value. And then we have a dummy variable creation. When it comes to dummy variable creation, what happens? Whatever the data frame will be having. If you have any categorical means similar to now, I mean, we have seen that gender column, right? If you have any textual data in your data frame, in that case, we'll be calling it as categorical data. So whenever you have a categorical data, most of the machine learning algorithms don't accept the categorical or textual input. To avoid that, what we'll be doing, we'll simply converting those categorical values into dummy variable creation. We'll be converting into dummy variable creation. What we'll be doing in dummy variable creation, we'll simply convert whatever the new, alphabetical values will be having in zeros and ones. In zeros and ones, we'll be calling it as dummy variable. In that dummy variable, we'll be having different types. One-hot encoding, dummy variables, get dummies also. And then we have label encoding. So these are the different types we'll be having based on the requirement. If we are going with the output encoding, in that case we'll be going with label. If we are doing for the input column, in that case we'll be going with one-hot encoding. When it comes to get dummies, if you want column names as well, in that case we'll be going with get dummies. And then we have a transformation. In transformation, what we'll be doing, whenever you have a data, if it is not symmetric, if it is right skewed, left skewed, if it is not symmetric, in that case, what we have to do, we have to convert that non-normal data to normal data. Non-normal data to normal data. That we will be calling it as transformation. Why we are converting that? Since whatever the algorithm that we are using, by default, we are considering that whatever the inputs or the data that we are taking is normal. But it is not the case always. In that case, whatever the non-normal data will be having, we will be converting into normal data. That is, we'll be calling it as transformation. And then we will be having the standardization. If we have a huge variance in the input data, x1, x2, x3. If it is the range of this x1 feature will be having in between 0 to 1, and the range of x2 we have about 10 to 100, and x3 is about in between 10,000 to 20,000. So here, this x3 will be having the more influence when you are working on some algorithm. To avoid that, we'll be going with standardization. So what we'll be doing in standardization, we'll simply converting different scale into one scale. Scale free, to make scale free data, or to make into one single scale, we'll be using what? Standardization, and then we'll be having normalization as well. In normalization, it is same. Standardization and normalization are very, both are will be using for same to convert to make the data scale free. In standardization, the data is converted in between -3.4 to +3.4, and the properties of those values are mean is equal to 0, standard deviation is equal to 1, and when it comes to normalization, all those data are transformed into 0 into 0, in between 0 and 1. And then string manipulation will be having. In string manipulation, we'll be using when you have string data, or data is object, or data is textual. So when we are using this textual data, it will be having the sequence. If you want to get the information of one particular index, in that case, it will be having sequence, right? When you have a sequence, you will be having the index function. Whichever the information that you want, you can easily access the information using the index only. Then we will be using the string manipulation. Whichever the information you want, you can simply access that information using the index value of that particular string data. So that is pre-processing when it comes to when it comes to structured data. And when it comes to unstructured data, similar to the structured data, we'll be having unstructured data as well. But in structured data, we'll be having all in the form of table. But when it comes to unstructured data, we would be having in the table format. In that case, we'll be having the pre-processing techniques, but those are a bit different compared to structured data. When it comes to text pre-processing, what we'll be having, if you want to do some, where exactly we'll be using, see, whatever the data that is available out there, 20% data only structured, 80% data will be having the unstructured data. And to do the pre-processing, we have so many techniques, like we'll be having text block, Keras, NLTK library, and we have sci-fi as well. Yeah, we have, these are the different libraries we'll be having to do the pre-processing. So what we'll be doing when it comes to unstructured data pre-processing, Spacey, actually, yeah, Spacey, we have BERT, we have NLTK. For these various tools, we'll be having something like Spacey, BERT, and NLTK. These are different tools. Using those tools, we can do the pre-processing. Okay, after extraction, first what we'll be doing when it comes to extraction of data, let's say if you want to do the sentiment analysis on which some product, let's say I want to do the sentiment analysis on one iPhone that is present in Amazon. In that Amazon, you will be having so many reviews, right? In order to access that information, I'll be using a library called Beautiful. So using this, what I'm doing the web scraping. I'll be going on that particular URL and I'll be going on that particular site, that is e-commerce site. Wherever I have, wherever I have those reviews, simply I'll crawl into that particular URL. I'll simply extract all those information. Whenever you are accessing all this information, in that case, we'll be having so much anomalies, like HTML tags will be having, and some spelling mistakes will be having, human error, spelling mistakes, and we'll be having special characters as well. And we'll be having some smileys, some emojis, you can say. So all these anomalies will be present on that particular data. In order to clean the data, we'll be using NLTK. You can use, these are the different tools we'll be having, but I'll be going with NLT, Natural Language Toolkit. So what we'll be doing in this very first one is we'll be doing tokenization. What is tokenization? Whatever the sentence that we'll be having, we're simply converting the sentence into single word. Whole sentence we are converting into single word. That we will be calling it as tokenization. Normalization, when you are doing the bag of words. If you have some like outliers, if you want to remove those outliers, kind of outlier thing only we'll be doing when it comes to normalization. Noise removal. So whatever the the information that is not required, like special character, @ percentage, all this information is not required to do the sentiment analysis. It doesn't represent any sentiment. In that case, it is a noise data for us. In that case, we have to remove those noise data. So here we'll be removing the noise data. So what are the pre-processing techniques? What are the different anomalies we'll be having? So we'll be having HTML tags based on the general outlier, various steps under the component. These are the different techniques we'll be using to remove those anomalies. Since we are extracting information from the HTML pages, we'll be having so many HTML tags. Remove extra white spaces. We'll be having the extra white spaces, that also we'll be considering it as anomalies. Convert accented characters. Now we'll be having the ASCII standard characters. Those also we will be removing. expand the contractions and remove special characters. These values won't represent any sentiment. In that case, what will be doing? Will simply getting rid of this, so that whichever the data that represent the sentiment, those data only will be taken into the consideration. When you have those data, using that data only, we can go with the sentiment analysis. In sentiment analysis, what we'll be doing? We'll be going with word cloud. For that, creating word cloud, we need a clean data. That is right. That is the reason we'll be removing this information, removing the data which is not representing any sentiment. And Python is case sensitive. Python is case sensitive. If you're writing use, these are all capital, small, capital. When you are giving something like this, everything, I mean, all are different. It will take all are different. Python will take this all are different. In that case, it will give 3 words. But it is not right. Use, it is just 1 word. But we are giving capital here and capital here and capital here. So it will take all are different. To avoid that, what we can do, we have to convert everything in the lowercase. So Python is a case sensitive. We have to convert all those things in the lowercase, and then we will be going with, we'll be proceeding with the data. Convert number of words into numerical form. So for that, we'll be using the count vectorizer to find out the term frequency, how many number of times that particular word is appeared. And then we'll be removing the numbers if you have any numbers. In that case, numbers also doesn't represent anything, right? In that case, we'll be removing that numbers as well. And we'll be having stop words. What are those stop words? Let's say you have a data in that, and as if. These are the words that doesn't represent any sentiment. You are doing for sentiment analysis. If you take this data, in that case, it won't represent anything, right? If you are writing some review, if mobile is good, or mobile, let's say we are talking about the iPhone. I want to do the sentiment analysis on that particular iPhone. Camera is good. Let's say camera is good. Like that, I had one review. In that case, camera, yeah, it is useful. I'm taking this in order to do the word cloud. Here is represented any sentiment. No. Here good, it will be representing the positive sentiment. So I'll be taking this and rest. This is, we'll be calling it as stop word. So we'll simply remove this data. Like that, we'll be having so many. And while writing, sentences, will be using so many, connectors. Different words will be using, right? So those all, I mean, whichever the words that doesn't represent any sentiment, we will be removing these. These words will be calling it as stop words. We'll be simply using the stop word filter, and then we'll be going with, we'll be removing those stop words. Whatever the rest words will be having, will be taking into the bag of words. Will be simply taking into the bag of words. So whatever the words will be having, if those words will simply converting into the root word form. So whatever the words will be having, let's say best. What is the root form of this best? Is good. If you have already good and you are giving one more good, in that case, whoever talking, awesome. These all represent the same, right? Good only. If you are giving this, in that case, this good word will become bigger when it comes to word cloud. Word cloud, what happens? Whichever the word are most number of times or in the document is represented, in that case, that word will be getting bigger, right? So using that, we can get an idea, like most of the people are talking about that particular product is having the positive sentiment. Like that, we'll be using. In lemmatization, what we'll be doing, I mean, this is the only we'll be doing when it comes to lemmatization. We'll simply converting that word into root word form. We'll be converting into the root word form, and then we will be supplying this data to word cloud, and then we'll be farming the word cloud. Just using those, we can do the inferences. So these are the pre-processing pre-processing techniques we'll be having when it comes to structured data and the unstructured data. So irrespective of any domain, we'll be having the same data set, right? Whether it is transportation, whether it is HR analytics, we will be having the same data. Whether it could be the structured data, and it could be the unstructured data. So pre-processing techniques will be applying on the same, right? It could be any domain. We'll be simply applying the same pre-processing techniques. So even though it is a transportation analysis or analytics, we'll be applying the same pre-processing techniques since we'll be having the same data frame. And data frame means what? It is a combination of anything. It could be numerical data. You'll be having numerical, or you might be having categorical data. In that categorical data, we'll be having so many nominal, ordinal, and this ratio. So like that, we'll be having so many, right? So it is, the data types are very similar for any data, domain. So we'll be doing the same pre-processing. So this is all about unstructured and the structured data pre-processing. Once it is done, whatever the pre-processing that we are done with, if we are done with the pre-processing, then we will be going with data mining, or you can say model building. So in the next class, in the next session, we'll be discussing about, yesterday we have seen, right, supervised. In machine learning, we'll be having two types, supervised algorithm and unsupervised algorithm. In next session, we'll be taking one unsupervised algorithm, that is k-means, and we'll see how we can apply the k-means algorithm in a real time, that is when it comes to transportation domain. We'll take one use case scenario and we'll try to apply the k-means algorithm, and we'll try to figure out how can we apply that algorithm, and what are the inferences that we can get from that particular algorithm. So this is all for today, guys, and I hope you guys have learned something, and thank you for joining. And if you want to kickstart your data science career, in that case, you can simply search Tame Python by Bharani sir. You can see 22 days of Python program. You can start learning the Python from there. And if you want to learn more things about different domains, in that case you can simply follow 360DigiTMG. Simply follow 360DigiTMG YouTube channel, and yeah. That is it for today, guys, and thank you for joining with me, and we'll see you in the next session, and yeah, have a nice day.